Next up, we have Ameen Soleimani, who is going to be talking about Rai, and Rai is a Ethereum-backed stablecoin for the DeFi ecosystem. And I'll let Ameen sort of introduce how he got started with this project and how Rai works. So please welcome Ameen.
Is it working?
You can see everything properly, yeah.
Cool, great. Thanks for having me. Yeah, so my name is Ameen Soleimani. I'm here to present Rai, Building a Money God, the co-founder of Reflexor Lab. So thanks for having us, ETH Global. So today I'm going to give an introduction about the project. I'm going to talk a little bit about what I mean by money gods. We're going to talk about control theory. I'm going to explain the Reflex Index, which is what Rai is. It's a new kind of DeFi asset. And I'll talk about our forthcoming proto Rai mainnet demo launch. I want to start with why decentralization matters. And it matters because some things are more important than countries. So blockchain networks are global public utilities, and Bitcoin is it's a store of value vending machine for the world. ETH is a globally neutral financial system. We want to keep them this way. There's a reason we build on ETH, and it's because we believe that it's going to be resilient. And decentralization is a tactical decision, maybe even a formation, something like a phalanx, where you eliminate the dependency on centralized leadership to reduce the payoff matrix for an adversary to attack. You know, if there's one guy who can topple the whole thing, then it's like super worth going after them. But if there isn't, and then it might not be worth going after anybody at all. So the long story short, if you want your financial infrastructure or any infrastructure to outlast your country, you should think about decentralizing it. So what is Rai? Rai is a new ETH-backed DeFi asset. It's stablecoin-ish because it's a reflex index. It's not quite a stablecoin. It is volatility dampened index of its collateral. So it's designed to resist sudden price movements, but it can drift over longer timeframes. It is a fork of MakerDAO's multi-collateral DAI. We thought that was a great place to start because it's been formally verified, doesn't have external dependencies, has a network of experts that understand it in depth. The system is governance minimized, so we're trying to remove governance as much as possible over the system. We want to have ungovernance meetings where, you know, the point is to stop having the meetings and figure out fully automating the system so it can run itself. One of the things that we have figured out how to automate is the interest rate. So we automatically set the interest rate that keeps the Rai asset stable. And the asset is optimized to be DeFi collateral. So it'll be low volatility. And we think that because it doesn't have the same counterparty risk that, say, USDC or USDT have, or even DAI, if you think about the Maker governance system as your counterparty, might be helpful. So Rai is being developed by Reflexor Labs. The CEO is a charming young man named Stefan Ionescu. He's a 22-year-old Solidity wizard in the UK. The team is 5 devs, including Stefan. I'm a part-time contributor. I just work here. We also have Nikolai, the technical co-founder of Maker, as our advisor, and we've raised $1.6 million from Meta Cartel Ventures and Paradigm Standard Crypto Variant and Robert. Rai was born of frustrations with multi-collateral DAI. So single collateral DAI in 2018 was pretty great. It had ETH as its only form of collateral. The governments didn't really do anything except set the stability fee. And the project cared deeply about decentralization. I'm going to play a little time capsule blast from the past.
But anyway, so the thing about this this entire model as a whole. I don't think that it's possible for this model to scale at all in the same way that DAI can, Maker can, right? Because they're not decentralized. So like, it's just like a different product essentially, because let's say, for instance, you're building a dApp. If you build it on top of something like Tether or TrueUSD, it's no longer a dApp, right? It just became an app because you're actually building it on top of a bank. And underneath your product, there is a bank that is essentially the platform you're building on, because they're the ones who, in a sense, they have to agree to everything you're doing. And if they don't, you're in trouble, because they will actually, I mean, they can and they will seize your funds, freeze them or whatever, right? Like,
yeah, so that was in 2018. And now it seems that, you know, with Makers and DAI by extension has sort of become more of an app than a dApp, because more of the collateral backing DAI at this point is USDC than ETH. And the governance has extended its reach to do a lot. I love this meme of Mariano slapping all the tokens into Maker. Oh yeah, one more thing. I mean, also note, like, SpankChain had like 400,000 of the DAI at the time. Like, we liked it because it was, you know, cypherpunk money, and then now it's a little harder to explain what it is and justify it. But so talk about money god thesis. So the idea of the money god is that it is possible to build a system that transcends human intervention and is thus treated with a sort of divine reverence, so to speak. You know, you have faith in the system. And so one of the things that you have to have is a perception of control as liability. And so if you eliminate these points of control, you can reduce the possibility that insiders will exploit the system, or outsiders will try to damage it or attack it through even regulation. And this increases its resilience. And then through minimum governance, you get social scalability. So instead of needing to trust some group of people to make the right decisions about what the interest rates should be, or you know, the risk tolerance for various things, you sort of just trust that the algorithm will continue to operate as it was programmed. And maybe it's less flexible, but you don't have to worry about the black swan risk of the humans failing. You certainly can worry about the technical risk, but the bet is that it's easier to scale. And you can see this with Bitcoin, right? Bitcoiners are willing to stake their lives on Bitcoin because they trust the system not to change on them unexpectedly. There's no group of people that can go and just change Bitcoin unilaterally, and they all basically enforce that norm. Another thing is to break the dependency on USD. USD is losing its purchasing power, and it might go away entirely. It doesn't seem wise for a god to tether itself to such mortal systems. And the last is longevity, because you want to design the system to outlast its creators and have that kind of framework when you're thinking about the design. And the idea is that if you do all these things, like, people interact with the system differently than they otherwise would, and you get people to buy in and commit to helping grow the system, because they know that the rules can't be changed by anybody. And you can see Vitalik's a fan too. So talk about control theory. Control theory is everywhere. It's the science of maintaining stability. In this context, the reason that we're interested in control theory is because we want to remove the control of governance over the system. So if we want to not have people voting on what the interest rates are, we have to have an algorithm that sets it, and we have to design the algorithm that it can sufficiently handle, crazy black swan events and your sort of day-to-day without needing too much human intervention. Ideally, there would get to a point where there's none. So a control system works like this. It has some output that you're trying to get to some desired state. It has some input that you're manipulating, and you sort of measure the output, and then you manipulate the input. And my favorite example of this for beginners is like a shower, right? You get into the shower, you know how hot you want the water to be. You have the input, which is the knob, and you're sort of twisting the knob to make sure that the shower eventually gets to be the right temperature. If you move the knob too fast, if your controller is too sensitive, then you're going to overshoot and you're going to get hot water and then have to, turn it all the way back and then, repeat the process. And so the whole science of control theory is to try to optimize the system to quickly achieve the desired target, but without overshooting too much. The most common form of controller is the PID controller. And the way the PID controller works is it combines these three terms, all derived from the error, the difference between what we want the system to be at and what it is currently at. So the proportional term is directly proportional to the current error. So if the temperature that we want the water is like 100 and the temperature is currently 105, that's if it was 110, then that term would be like twice as big. So that just points in the direction of what the error is. And you can think of that as like the sort of standard, okay, well, if it's hot, then I should oppose it. If it's cold, I should, the integral is different. The integral, it accumulates the error over time, and it's typically used to deal with steady state error. So if there's a small amount of error that the proportional term isn't quite sensitive enough to pick up, it'll build and build and build over time until it is large enough that the integral term grows and responds to it. And so you can think of this in the context of like cruise control. Maybe your car is good at, if you have the set point to 80 miles an hour, if it's like 1 mile per hour lower and it's staying there for a while, then there's something that'll eventually bring it back up to 80. The derivative is based on how fast you are approaching or moving away from the equilibrium. I'm not going to talk too much about that. It's not as relevant for this, but it's another way to quantify the error. It's typically used for more fast responses. So when we're building this algorithm, we're essentially tuning a controller. And so each of these terms has a constant associated with it called the gain. There's a KP, the KI, the KD. So there's proportional gain and integral gain. And our objective is to determine what these parameters should be so that the interest rate responds and keeps Rye stable. And we're going to take a little field trip. It's going to be a few-minute video of watching a man stabilize his robot.
So yeah, let's start again and look at just proportional control and how to pick the gain and what it looks like if you go too high or too low. All right, so I've got the robot laying on its back right now, and I took the, if you look at the bottom three charts, I took the integral and derivative part, the gains, and zeroed them out so they're basically not having any effect. We now just have a proportional control feedback loop. And let's take a look at how that performs. So, because it has the gain that I chose earlier, it's actually balancing it right. But let me try to get this all in frame so you can see it a little better. See if I can get that.
This is the kind of thing we do at Reflexer.
All in frame. Okay,
yeah.
So that's
stabilized.
About as good as I can get. Okay, so if you look at the bottom left chart, the P scalar or P gain chart, well, first let me drive it around, I guess. So you can kind of see that it balances okay, but not very well. You kind of see that whenever I give it an input, it kind of oscillates a little bit. And that's even with the proportional gain set pretty well. If you set it much lower, so if you can kind of see now on the TV, I've got the gain set at about 5,000, and now it just really doesn't want to balance. I have to kind of constantly, I have to kind of manually balance it. It's just kind of all over the place. So yeah, if your proportional gain is set too low, it's just going to drift. It isn't going to hold its position very well, and it might even flip over. Okay, so if you raise the gain, so we're going to bring it up towards about 12,000, which is where it was. You can see that it'll work all right. It still drifts quite a bit, but now it can, if I get that in frame, now it can, reasonably well on its own perform, but it still drifts a lot. And then if you set the gain way too high, so you can kind of see right there, the gain is set to 24,000. It balances a little bit better, but then it'll oscillate, and you can even see in the graph. Yeah, so that's one thing you got to be careful with. If you set it too high, it's it'll get kind of ridiculous. So for my particular robot, a proportional gain.
Cool. Yeah, that was it. So the point of that is that is actually what we are doing. Except instead of keeping a robot up, we're keeping the price stable, and we're not fighting gravity and whatnot. We're fighting market forces, and we our tuning process and what we'll try to accomplish with our mainnet demo and building the system over time is understanding the dynamics of the market to properly tune the parameters so that this thing can be stable in a variety of conditions. One of the interesting things that I learned in the process of this was that central banks actually sort of run on control theory. They just don't know it yet. So they have these policy rules of thumbs. Most of them derive from this Taylor rule, where you've got this inflation gap pi and the output gap y, and they determine the federal funds rate, the interest rate r, and you know, some of them have historical terms like the integral and so forth. And if you break down many of these policy rules, they're actually all fit into the same terms that a PID controller would have in terms of forward-looking and backward-looking adjustments. So let's talk about what RAI is as a reflex index. So to understand what RAI is, you need to understand these concepts. So the concept of the redemption price. It's different than in something like Maker, because in Maker, the redemption price is sort of always one DAI equals $1. That's the meaning of it having a peg. In this case, the redemption price is the value of RAI internal to the system used for the collateralization ratio, same as Maker, but it's in dynamic equilibrium with the market price. So the redemption price can change over time, and it gets set by the redemption rate. And so the redemption rate is the current rate of change of the redemption price. And the redemption price doesn't really matter what it starts at. It can be sort of arbitrary. So and then the redemption rate feedback mechanism is what updates the redemption rate in response to differences between the redemption price and the market price in order to make those two reach equilibrium and keep the ultimately redemption, the price of RAI stable. So here's the two sort of loops. So if the price of RAI goes up, people start buying RAI. Then the redemption rate of RAI goes negative, which means the redemption price of RAI starts to drop. And so if you are a holder of RAI at that point, you are effectively getting a negative interest rate. You are essentially paying to hold RAI. And so some of those holders might want to sell in order to avoid that negative interest rate, and in which case RAI would return to its equilibrium. And I say new here because when the redemption price starts to drop, like it'll go it'll continue to change until the market price reaches it. It won't go to what it originally was. It'll end up, you know, having drifted some from its original set point. And the same happens in reverse. If the RAI price goes down, then the redemption rate goes positive. Suddenly, if I'm holding RAI, I'm being paid to hold RAI, and if I'm borrowing RAI, then I'm paying extra interest on my loan. The redemption price starts to increase, and so RAI borrowers who don't want to face that interest buy back RAI to pay their loan, and then RAI returns to its new equilibrium. I got a message in the chat. How do I check that? Oh, cool. Right, so this is like what that looks like in practice. So this is on the right, and on the left, this is the same chart. The 2016 data science that MakerDAO did to try and simulate how the TRFM, as they called it, target rate feedback mechanism, would work. The market price, the terminology is a little bit different. So we renamed target price to redemption price and deflation rate to redemption rate. But ultimately, it's sort of the same. You can see that this system introduces a shock between days 5 and 15. So on day 5, the market price spikes, and you can see it up here too. And in response to that, the interest rate drops a lot, and it keeps going until the market price reaches equilibrium. And once it does, then the two sort of remain in equilibrium for another several days until the shock wears off, and at which point the market price rebounds. So the interest rate then rebounds in the opposite direction until it reaches equilibrium again. And note that the final redemption price, given that this redemption rate has sort of been between 1 and 3, it's positive this whole time, is slightly positive, and so it is not pegged to anything. It is actually increasing. So yeah, the behavior of the reflex index. So when you think about this in terms of a financial product, what do you expect it to do? Well, you expect it to resist sudden price movements, and it's essentially using these interest rate based incentives to counter that and create its own little gravity well. But on the long term, the price should follow the demand for ETH leverage, with the assumption being that demand for ETH leverage, with the assumption being that ETH leverage is also correlated to ETH price. So on the long term, we expect this to sort of follow the ETH price. And the mechanism for that is when people are leveraging ETH, they leverage ETH RAI, so they borrow RAI, they sell the RAI, they buy more ETH, they borrow RAI, they keep doing that. And this pushes up the price of RAI, but then over the longer term, this pushes the redemption rate, pushes the price of RAI down, which pushes the redemption rate positive, and over time increases the redemption price. So you could see that equilibrium will shift over time. And then the other thing is we want to optimize RAI in terms of shock recovery time. How long does it take the system to reach stability again, minimize overshooting, and add an amount of manipulation resistance. And so that's like, how expensive is it to somebody to introduce instability into the system by, for example, messing with the controller, buying a lot, pushing the controller one way and then selling and then moving it the opposite way, and essentially doing Oracle manipulation. And another goal is, of course, to maximize for RAI ETH liquidity, which would reduce slippage to make it cheaper to enter and exit into RAI as a system. So our progress thus far, we've been pretty busy. We converted multi-collateral DAI to English, so it doesn't have weird names anymore. Built all the smart contracts, including the control system, built the subgraph, the keeper, liquidation bots, TypeScript libraries, developer docs, did the historical data analysis on Maker, we calibrated our CAD/CAD sims, and we are now preparing for our mainnet demo. This is what it looks like to calibrate our simulations with our Solidity code. So at the top, you can see the Python. At the bottom, you can see our Solidity, and they look pretty much the same. So the left you can see is y-axis is the target price, and on the right, you can see that's the interest rate. That's the redemption rate that's being set. This is important because if they didn't match, then our simulations would produce parameters that were not super helpful in production on real Ethereum. We've also made schematics like this in building this. If this kind of thing turns you on, please proceed to our documentation. We'd love to work with you. Proto RAI. So we are launching our first mainnet demo in 4 weeks. There's going to be a 10,200 pry limit. It's about $2, so like 20,000-ish total. It's just meant to be a game to see how people interact with it. We try to leverage long ETH RAI. We try to mess with the controller and test out our system. So if that sounds fun to you, please come and join that. And if you're a control freak, please join us and help us taking blockchain control theory from 0 to 1. We're proud to be working with Block Science with Michael Zargum, who made CAD/CAD, our sim software, and we are interested in working with anybody else who's interested in this as well. So, yep, that's all I got.
Amazing. Thank you so much, Ameen. That was a great lesson in not just what RAI is, but also a good refresher on control theory. That definitely takes me back to some of my college courses. There are a handful of questions that have come up, and what I'll do is I'll kind of ask you a couple of them here, but just to kind of keep everything moving along on time, I'll encourage you to kind of join the chat after this if you have time and just answer those people directly. But the first question that I have is actually for me, and that is, there's a lot of reinforcement and kind of information you need to do and kind of improve on for the control systems to work. So I'm actually just curious, are there any limitations on what you can do on smart contracts with respect to designing a perfect control system or feedback loop here? And like, is there anything that's not possible? Or like, is everything just fine and works really well in kind of how you're envisioning RIDE to be?
Yeah, that's a good question. So we're fortunate that most of the even like more sophisticated control systems are mathematically efficient. So they're relatively easy to build on smart contracts. There is like, gas thinking to do
Right.
because you have to think about how often you update the system and how expensive it is to update it often. And if you can, for example, update it less often, but there's always a trade-off when you're doing that, right? So
Awesome. And the second question we have from our chat, and I'll just say this verbatim. What is the incentive to redeem RAI when the redemption rates go negative? Shouldn't they just wait until it rebalances on its own or when they are ready to redeem?
what is the incentive to redeem RAI? So if the rate's going negative, so that means there's a lot, the price of RAI goes up, so the rate goes negative. I mean, like part of it is arbitrage. I mean, why do people redeem DAI when the price is up? Part of it is that if the price is currently like, I don't know, let's say 1.1 relative to its starting position, and the interest rate is -10, then you know that it's going down. So you want to get ahead of that interest rate. If that doesn't bother you, then you can hold. And anybody who that bothers can take that action.
No, I hope this clarifies the question for the person who asked us on the chat. So thank you so much, Ameen. We have posted Ameen's slides on our chat. So if anybody's interested in looking at the deck, you can just click the link there. And for any other questions that you have for Ameen, we'll either relay them to him directly or he'll join the chat and answer them directly to you. So thanks so much. And thanks again for your time.
Thanks for having me.
With that, I'd like to